Okay, let's dive right in. We're tackling high-end AV distribution today.
Yeah.
Specifically, we're looking at this WolfPack 4K 30 Hz 6x8 AV over IP Matrix Switch. Quite a name.
It is. And our job really is to unpack what this system actually does, especially considering the price tag. It's around, what, $4,475?
Exactly. So the goal is to see how it handles something demanding like 4K video over a standard network without, bringing everything grinding to a halt.
And figure out what advantages you're getting for that kind of money.
Right. So the basics, it's a 6-input, 8-output matrix. Any of those 6 sources can go to any or all of the 8 destinations.
Standard matrix function, but the how is interesting.
Definitely. The specs mention 4K at 30 Hz, sending signals up to 450 feet using just a single TT6 cable.
And it uses PoE, power over Ethernet.
Which is great, less clutter, fewer power bricks needed at the display end. That alone simplifies things quite a bit.
It does. But the really crucial part, I think, is how they manage the bandwidth. They're using H.265 compression.
Okay, H.265, that's pretty efficient.
Super efficient. And the claim is, even when you're pushing 4K 30 Hz or even one of those quad view outputs.
Where you see 4 sources on one screen.
Exactly. Even then, the total bandwidth needed on the network stays under 1 gigabit.
Wait, hold on. Only 1 gig? For potentially multiple 4K streams or complex views, that seems almost too good to be true. 4K usually eats bandwidth for breakfast.
It does. That's the engineering challenge they seem to have focused on. Keeping it contained within that 1G pipe is a major selling point for IT departments, you can imagine.
I bet. No need for a totally separate, super high bandwidth network just for AV.
Right. It plays nicer with existing infrastructure. And speaking of infrastructure, the hardware itself is interesting. The transmitters, the TX units.
The ones you plug the sources into.
Yeah. And the receivers, the RX units at the displays. They're actually the same box.
Oh, so you don't buy specific TX or RX units?
Apparently not. They're identical hardware. You just tell the system via software whether a specific box should act as a transmitter or a receiver. That's pretty flexible for deployment.
Okay, that simplifies inventory and setup for sure.
Yeah.
But back to the performance, you mentioned compression. What about latency? That's always the worry with AV over IP.
Good question. The spec sheet mentions a low latency mode, quoted at about 50 milliseconds.
50 milliseconds. Is that noticeable? Like if you're switching channels or using a mouse?
For just watching video or switching sources in most scenarios, 50 meters is generally considered very, very low for a compressed system. You likely wouldn't perceive it. They also mention KVM support.
Right. Keyboard, video, mouse. So you can actually control a source device like a PC remotely through the same system.
Exactly. All running over that same efficient 1G network path. Which brings us to what seems like their standout feature.
Okay. What's that?
The real-time preview capability. You can use a wireless iPad or an Android tablet and see a live, full-motion video preview of all your active source devices simultaneously.
Whoa, wait. Not just static thumbnail images, like actual moving video.
That's the claim. Full-motion video. So if you've got, say, 12 different DirecTV boxes feeding into the system,
you'd see all 12 channels playing live on your tablet screen.
Apparently so. It's like a little command center in your hand. You can see exactly what's on ESPN before you switch the main conference room display to it.
That avoids the whole switch, wait, oops, wrong channel, switch again, routine. I can see how that would be huge in sports bars or control rooms.
Definitely speeds up operation. They market this pretty heavily, saying it's only at HDTV Supply, which is the vendor. One important note, though. The tablet preview itself doesn't include audio. It's video only.
Makes sense. Probably keeps the tablet app lighter and avoids audio chaos. Okay, so beyond the preview, what else can it do? It's not just a simple matrix, then.
No, it's quite versatile. It supports video wall configurations. Think like a 6x8 wall or maybe a 3x3. You can set that up using their PC software.
And can you do fancy stuff like rotate parts of the image for creative walls?
Yep, the software allows for 90, 180, and 270-degree rotation.
Oh,
Plus, it handles seamless switching. They quote that at around 80 milliseconds.
So pretty quick transitions between sources.
And it's built to scale. You can apparently expand the system way beyond the initial 6x8 up to potentially 100-plus displays by adding more units and cascading network switches.
Wow, okay. That's serious scalability. What about audio handling in general?
They've thought about that too. The transmitter units handle the embedded HDMI audio, as you'd expect.
Right.
But the receiver units, the ones in the TVs, have a 3.5 millimeter audio output jack.
Ah, so you can de-embed the audio, pull it out separately.
Exactly. You can strip the audio off at the display end and
Yeah.
send it to a separate amplifier or sound system. Really useful in commercial setups where the built-in TV speakers just won't cut it.
Okay, that makes a lot of sense. So wrapping this up, the core idea seems to be balancing act, right?
I think so. It's about using smart H.265 compression to keep the network load minimal, down to that 1G limit.
While also maximizing the usability and control with things like that real-time tablet preview and the flexible hardware.
And offering scalability for really large setups, plus features like video walls and KVM. It's designed for flexibility.
So here's something to think about, building on that scalability point. The system can grow huge by cascading network switches.
Right, creating potentially massive matrices.
Exactly.
Right.
So the question for you, the listener, is this. Even with the software tools they provide, like DFU and DVStool, what are the hidden complexities? What are the real-world logistical headaches you might run into managing potentially hundreds of IP addresses and intricate routing configurations across such a sprawling AV network? Something to ponder before you design that stadium-sized video system.